All right, let's take a look at section 6.6. This is the last section that we're actually going to do here in chapter 6. So this is complex fractions. And a complex fraction is basically a fraction where the numerator, the denominator, or both are also fractions. So like this one, 2/3 over 5/5. Isn't that a fun fraction? You've got a fraction on the top, a fraction on the bottom. Looks a little bit scary, but it's really not that bad. Here's why. All a fraction really is a division problem. And so what we have here is the same thing as having 2/3 divided by 4/5. Make sure that the top part of your complex fraction goes first. That's really important. And I recommend setting it up as a division problem before we move on, just to be safe. So we know that when we divide fractions, we can flip the second fraction and multiply. So we multiply straight across, you get 10 over 12. They're both divisible by 2, so we get it down to 5 over 6. And our first example then ends up being 5 over 6, and that's really how a lot of this is going to work. Okay, so we're going to have two basic kinds of problems. This kind has numbers, and this one, which also has some letters, these both are going to work essentially the same way. And then we'll see a different kind of example on the next page. All right, so this one has letters in it. The key here, though, is that nowhere in here do we have addition or subtraction. If you have addition or subtraction, it's really going to make you have to do it different. Okay, we can only do this kind of multiplying and reducing kind of stuff if we don't have addition or subtraction. So we'll cross that bridge when we get there. But for now, again, I have this complex fraction. It's a big ugly mess. So I rewrote it as 3x squared y over z divided by 6xy over z cubed. Okay? Pretty weird and messy looking, but that's right, we'll make it work. We take our division, we change it to multiplication. We flip our second fraction upside down, okay, just like we did back here. Same process. So now we have to multiply to get to the answer here. And so I kind of skipped a bit, and I'll kind of show you what I did here. First, I dealt with the 3 and the 6. Okay, you got to keep in mind that we're multiplying straight across. I can reduce numbers that are divisible by the same thing. Since 3 and 6 are both divisible by 3, you get a 1 over 2 for the numbers. For the x's, I have x squared here, and I have x on the bottom of the other one. So I can get rid of one of them down here, and one of them up there, leaving just the single x. With the z's, let's do the y's. The y's are going to completely go away. Right? I've got one on the top, one on the bottom, they're gone. That's why you don't see any y's over here. The z's are a little bit different. Keep in mind this is z to the first power right here. And so we have 3 there, we have 1 there. We can get rid of one of them, but if we get rid of one, it's going to leave us with z squared. Okay, so then we take all those pieces that we have, once we reduce it down, and we get over to here, and we're pretty happy with it. And that's how these, I'm going to call these more basic, but there's certainly nothing terribly pretty about this kind of problem either. So do a bunch of problems, get really good at them, and definitely let's look at what else we have. Okay, so here we have another example. This time you'll notice we have addition in the problem. Anytime you have addition or subtraction, it's going to change how you have to go about doing it. Okay, because we can't just flip and multiply. It's not going to work out well. The addition really messes with it. So instead, here's what I'm going to do. I'm looking at the fractions that I have in the numerator and the denominator, the 1 over the y and the 1 over x. I need a common denominator. Common denominator here is xy, because basically x and y, we have no idea what those are. They can be anything. They might have something in common. They might not. We have to just use them both for our common denominator. And so what I'm going to do then is, you'll see here, I multiplied the top and the bottom both by that common denominator. And here's why that's really nice. Well, we'll see here in just a second. So what we're going to do is we're going to distribute the xy to the pieces inside our parentheses. when I do that, x times xy is x squared y. But notice what happens with the 1 over y times the xy. The y will cancel out because this y, it's like it's on the top of a fraction, and this one's obviously on the bottom. So those y's will go away, and you're just left with 1 times x, which is x. The same thing happens on the bottom. Y times xy gives me x times y squared, but then when I get to the fraction, the bottom part of that fraction cancels out, and we're just left with y. Okay, so that's really what we're looking to have happen here with that common denominator. We're really looking to make sure that it gets rid of everything that's on the bottom of these little fractions that we have. So now we get here. It would be nice if we could reduce this fraction, but we can't just start crossing out letters because, again, we have addition in the problem. So we have to take care of that. The only way we can reduce this is to factor. X squared y plus x has a common factor of x. So you'll notice I pulled out that x. X divided by x gives me the 1. And on the bottom, the common factor is y. So I divided both parts by y. The y goes out front. And now we have a common factor. The xy plus 1 is a common piece on the top and the bottom. And since it's connected by multiplication, we can get rid of it even though it has addition in it. Right? It's this x times the parentheses. It's the y times the parentheses. So since those parentheses match, we can get rid of them. All right, we're going to do one more example. All right, one more example. So this time, we notice again we have subtraction. It actually doesn't make any difference if it's addition or subtraction. Either one is going to basically cause us to have to do the same thing. So I'm looking at my 3 little fractions. Okay, I have one big fraction. I'm looking at the 3 little fractions. My common denominator here is x squared. Okay, long story short, just pick the one with the biggest exponent. So this x has an exponent of 1. Those are both 2's. 2 wins. X squared will be big enough to do the job for what we need it to do. What we needed to do is get rid of those little fractions. So let's take a look. So if I multiply the top and the bottom by x squared, you'll notice we do 1 times x squared and get x squared. Then we do 4 over x squared times x squared. And again, it's like this x squared is over 1. And that allows it to cancel out the bottom of the fraction, leaving us with just the minus 4. When we do it here on the bottom, 1 times x squared is x squared. The middle one, this only has one x on the bottom, right? It's just x to the first. So it's going to go away, but it's going to it'll still leave us with x. So 1 times x gives me the minus x. But then when I do, so we'll write that back in. When I do this one, again, the x squares will completely get rid of each other, leaving the minus 6. So if we just use the biggest exponent that we have, that will get rid of all those denominators for us very nicely. So then we get here, we need to factor this. I'm not going to spend a whole lot of time showing you how this factoring works. Go back and check the other videos for how to factor this, but this is a difference of squares. So since 4 is 2 to the second power, we get x plus 2 times x minus 2. This is a trinomial. If you trust me, it multiplies to be x minus 3 times x plus 2. Again, if you need help figuring out the factoring, go back and look at the videos from chapter 5, and that really should set you straight here. So then I cross out, get rid of the pieces that match. Both the top and the bottom have a piece that is x plus 2, and we're left with x minus 2 over x minus 3. Notice I didn't put parentheses around either one of those. At this point, we don't need them because there's nothing else on the top and nothing else on the bottom. But would it be wrong if you left the parentheses around those? No, it wouldn't. Not at all. You can go right ahead. Leave those parentheses there if it makes you feel better. Either way would be just fine. So there you go. Thanks.